Welcome back. Let's dive back into workload management system concepts. It's time to find out more about the resource manager. The resource manager is responsible for monitoring and maintaining the resources used by the job scheduler to run jobs. What are these resources? All nodes in the cluster have well-defined resource attributes which allow them to run jobs. Examples of these include the number of CPUs, amount of memory, type of interconnect, etc. These will be further explored in the next morsel. Nodes are often grouped into partitions. These partitions are collections of compute resources where resources are combined according to what types of jobs they will run best. Just like you need different tools to use a screw versus a nail, different jobs require different combinations of hardware resources. Grouping these resources into partitions is a way of organizing the cluster to work in the most efficient way. The resource manager is also the party responsible for keeping track of which resources must uphold which usage policies. An example of this is if a node can be used by multiple jobs, known as shared usage, or if it must maintain exclusive usage rights for a job. We've covered resource management. Now what about job scheduling? The essence of job scheduling is scheduling, planning the execution of a job for a certain time. Also included in this plan is on which processing units the job will run. In order to plan this appropriately, the job scheduler must know what resources the job needs, the expected length of the job, and how important the job is, among other things. These directives are contained in a job script submitted to the batch system by the user. In the event that the resources aren't immediately available, the job will be added to the job queue. Much like any other queue where you stand and wait your turn, the job queue is where the job sits and waits when they have been submitted but haven't yet had a chance to run on the cluster. Remember when we were talking about resources? Well, recall me saying that resources are grouped into partitions which, like tools in a toolbox, will have different shapes and sizes depending on which job they are required to perform. How do we make sure that jobs we submit to the scheduler end up running on the resources in a particular partition? Easy. Most of the time, each partition has its own job queue. Let's walk through an example. Most of the resources in a cluster are dedicated to running production jobs. These are full-size jobs that may last multiple hours or days. This makes sense because this is what the system is predominantly designed and used for. But say, for example, we want to debug some code on a small part of the cluster. What do? We have production and debug partitions, each with their own queue. In this way, a small portion of resources are kept available for running testing applications, which are much smaller and far shorter lived than production jobs. There are two ways of choosing a job queue. The first is to specify it as the user, and the second is to submit a job script with detailed resource requirements and allow the scheduler to pass the information and choose an appropriate queue for the job. In the following sections, we will further explore the job scheduler, look at some policies implemented to order jobs in the queue, and work through writing our own job script file.